Hi guys, in this video we're going to talk about section 1.7, function notation. So one of the most common things you'll see in functions is this phrase right here, f of x, and that's how you read it, f of x. Now this is not f times x, so that notation can be a little bit funky, but know that f of x is just the same thing as y. So I could also write y equals 5x plus 3, and I'm talking about the exact same function. So you might ask, why the heck then do we have a different notation? Well, the reason why we like function notation is it allows us to evaluate functions and see the input and output at the same time. So here's what I mean by that. F of 1. So what this is saying is they want us to substitute 1 in for every x value. So if we do that, I'm using this function here. So 5 times 1 is 5, plus 3 is 8. So f of 1 equals 8. So here I can see the input was 1 and the output was 8 at the same time. Where if I just have y equals 8, I don't know what the input was. So that's why we really like function notation. The other thing that's useful here, 1, 8 is a point that is on this graph. So again, it's giving us an ordered pair, an x and a y, that are associated with this function. Here's kind of the phrase how we can say it in words, you guys. So f of 1 equals 5 minus 1 plus 5 times 1 plus 3. So that's saying this in words. Here saying this in words, the output you get when the input is 1 is 8, would be kind of finishing that if we were saying this in words. Okay. So I kind of talked about this already, but f of x is y. So when I put in something for x, I'm getting an output of y. So I get an ordered pair x and y, or x and f of x. Okay, so let's practice evaluating another one. So f of negative 1. So we're putting in negative 1 for every single x. Okay, so I have 2 times negative 1 plus 7. So 2 times negative 1 is negative 2. Plus 7 is 5. So f of negative 1 equals 5. So 5 is my solution there, but again, we like to write it all out together because then I can see the input and output at the same time. Try this one. So f of 0, we're putting in 0 for every single x. So 0 squared is 0, minus 4 times 0 is still 0. So f of 0 equals 0. That isn't always going to be true, you guys, so don't get in the habit of that. That's just true for this particular function, that the point 0, 0 is on that graph. So now we're plugging in negative 2 into that same function. Okay, following order of operations, so square this guy first. So 4, and then negative 4 times negative 2 is a positive 8. So 4 plus 8 is 12. So when we put in negative 2, we got out 12. Okay, looking at this graph, we can actually evaluate functions as well graphically. So let's take a look. I'm going to add arrows on here, you guys. The domain and range. So domain is left to right, which those arrows indicate it's going to go forever to the left and forever to the right. The range is low to high with y values. And again, because of those arrows, it's going to go down forever and up forever. So my range is also all real numbers. Okay, f of 0. So remember, this input is an x value. So I'm asking, what is y when x is 0? So I'm going to go find x is 0 here, and I'm going to go up till I hit the graph and look at what is the y value there. So in this case, it is 3. So when x is 0, y is 3, so the point 0, 3 should be on this graph, which it is. Okay, negative 2. So we find negative 2 on the x-axis, go up to the graph. What is the y value there? It is 1. So f of negative 2 is positive 1. Now this is asking the opposite. What is x when f of x equals 4? So f of x is y. So we're looking at when does y equal 4? So if I kind of draw a line through here, this is when y equals 4. So what is the x that goes with that? Okay, well, that happens when x equals 1. Okay, so kind of asking it in the reverse way. And that is it for this video, you guys, 1.7 function notation.